Welcome back to Physics 30. This is the third booklet in the acceleration section. So it deals with pages 93 to 97 of your book. And here we'll be looking at analyzing velocity versus time graphs to determine an object's displacement during a time interval. So previously we looked at using a VT graph to figure out acceleration. This one is going to be used for displacement. And it's really, really easy. It's just simply the area under the graph. If you have meters per second and seconds, if you multiply those two quantities, you'll get meters since the seconds cancel out. So we're looking at the area here. So if we had a graph that had a constant velocity during a specific time, you can see how this works. Area is equal to length times width. If we think of this as a rectangle, length times width gives us area. In the case of velocity, displacement, and time, v is equal to d over t, or if I take velocity times time, I in fact get displacement. So 10 meters per second multiplied by 5 seconds, and you can see that works out to be 50 meters. So this works if my velocity is constant throughout. Simply taking the area of that graph gives displacement. If it's not constant, let's say an increasing line or a decreasing line, if you take the area under that, you'll in fact get a triangle. So the area of a triangle is 1/2 the base multiplied by height, and that'll ensure you can get that one. So we deal with simple cases in Physics 30, just simply rectangles, triangles, curves. That will be what you will be doing in calculus if you take that eventually. So if we look at some of your graphs here, yours are much neater than mine, but they get the point across regardless. So here we have a graph in which 3 hours, we're going at 80 kilometers per hour for 3 hours. So of course 80 multiplied by 3, 240 kilometers. Here, if our velocity increases from 0 to 15 in 15 seconds, of course that's half the base multiplied by the height, so that'll work out to be positive 112.5 meters. So again, half of the base times the height, half of 15 multiplied by 15. Maybe pause the video at this point and see if you can figure out the remaining ones, the remaining 4 or so that we have. Okay, if you had a chance to do that, again, we have a triangle here. So 1/2 the base multiplied by the height, 1/2 of 6 times 8 plus 24. Notice I put the sign in front of this too, indicating that it is a positive movement. In this last case here, we have both. We have a region in which we're going from 0 to 30 meters per second, then staying at 30 meters per second. So think of that as two separate cases. We have a triangle and we have a rectangle. Be careful here with this length here though. We're from 6 to 12. That is in fact 6 seconds have elapsed by in this area. 6 seconds have elapsed in this time. So just be careful of that. Don't refer to this bottom rectangle as 12, which is a common mistake that some people make. So what we do there is we combine both of those areas. So 1/2 of 6 times 30 combined with or added to 6 times 30. And we get plus 270 meters as a result. Okay, if you had a chance to do the last two here. So here we have a situation in which we have two triangles going from 0 to 6, then reducing from 6 down to 0 again. So our base is 2 in this triangle. The base is actually 4 in this one, the difference between 2 to 6. So 1/2 of 2 times 6 plus 1/2 of 4 times 6, and we get positive 18. In this last one here, we have two triangles and a rectangle. So 5 here, in between 5 and 20, that's a movement of 15. And in between 20 and 30, that's a movement of 10 seconds. So of course, 3 separate scenarios are 1/2 of 5 times 15, then 15 times 15, then combined with 1/2 of 10 times 15. So we get 337.5 meters in the positive direction. Okay, to end off this, we have a question involving a speeder and a police cruiser. So your graph looks a little bit neater than mine, but I kind of marked mine up a little bit from answering the questions here. So we have a speeder going at 30 meters per second, and I just determined how many kilometers per hour it is by multiplying by 3.6, 108 kilometers per hour, so it could be a city zone there where the speed limit's 50, who knows. So the speeder is going at a constant speed at 30 meters per second. The police officer sees it and pursues the person going, so starting off at 0, increasing until 40 meters per second, and of course stays at that constant speed, and eventually will overtake the speeder. So if you take a look here, what is the police cruiser's acceleration? So in order to get to 0 to 40, there's acceleration there, of course. So acceleration is change in velocity over change in time, or v2 minus v1 over t2 minus t1. So our point 0, 0 and the point 10 comma excuse me, 40. I think my graph's a little bit off here. So 40 minus 0 over 10 minus 40 plus 4 meters per second squared is the police officer's acceleration. What is the displacement for each of the two at that 10-second mark? So you can see the speeder will simply be constant speed of 30 meters per second after 10 seconds. This forms a rectangle, so this is 30 times 10. Whereas the police officer, it's actually a triangle, half the base times the height. So we can get an idea as to how far each have gone. The police officer, it forms a triangle shape. The speeder is a rectangle shape. So 200 meters versus 300 meters. So the police officer hasn't quite caught up yet. And then, so how far apart are they? They're 100 meters apart if we take that difference into account. And then the last question, of course, is when will the police officer catch up to the speeder? So what I did here is I just looked at particular sections of 2 here. I think your graph goes up by 2 seconds. So every 2 sections here, I just simply added that on to the existing amount. So if I look at what the speeder's doing, after 2 seconds, still going 30, so 2 multiplied by 30, we'd be adding 60 meters onto the speeder for every 2-second interval. Whereas the police officer is going at 40, so 2 times 40 is 80, of course. So we add on 80 to each of the police officers' intervals of 2. So that's all I did there. So after 10 seconds, of course, they're each doing this. And as mentioned, 2 seconds later, we add 80 onto the police officer, add 60 onto the speeder. So eventually they get closer. So maybe pause the video here and see after how many interval of 2 seconds will they be neck and neck. Okay, if you had time to do that, so add another 80, add a 60. Add another 80, add 60. Add 80, add 60. And of course, add 80, add 60. So it looks like after 20 seconds in total, the police officer will have caught up with the speeder. So again, we're looking at figuring out the displacement under a velocity time graph by figuring out the area. And we look at simple cases involving rectangle shapes, length times width, or triangle shapes, half the base multiplied by the height. Okay, see you next time.